Okay. Trust me when I say you are going to enjoy this part of electric circuits. I've just made some sketches of the circuits that I would like for us to go through in today's lesson. So I will just, start in a different way where I'm just going to go straight into the calculations so that as we continue, everything will build up and based on what I'm going to start with. So these are the main three questions that we are going to be looking at. The first type of a calculation that I would like for us to look at, it is to calculate R tot being R total, and then the second type of a calculation, it is to calculate the current, and then the last one, it is to calculate the voltage V. Yes. Okay. Then it's fine. Let me just draw and say we've got an electric circuit there. Just a simple one. Let's say this is 20 volts, and then this is 1 ohm. This is 2 ohms. Let's say this is 3 ohms. Okay, then it's fine. This is what you are having. And most importantly, before you can do much, you need to ask yourself, what type of connections am I having there? It looks like it's only a series connection that you are having where the current will just flow nicely without splitting. So it will just continually do like that. So when it comes to calculating R tot, remember we said it's only one formula to calculate R tot. So that means in calculating that first question, in physical sciences, you firstly identify the correct formula, then you write it down, where you will therefore say capital letter R, and then you say tot for total, then it will be R1 that you plus it with, R2 that you plus it with, R3 that you plus it with any other resistors which may exist in that particular electric circuit. So in this case, we only have 1, 2, 3 resistors. It is your small charger there, it is the TV, and then it is the stove there. Okay, so now in terms of calculating R tot, it means in this case, we will therefore say R tot equals 1 ohm plus 2 ohms plus 3 ohms. And then that plus that is 3 plus that is 6. Most importantly, in physical sciences, you get full marks if you show the unit, because we don't know if that 6 is your age. You need to make sure that you specify. Nice thing about physical sciences is that you identify the correct formula, we mark you with a mark. Correct substitution, we mark you with a mark. Correct final answer with the correct SI unit, we mark you with a mark. So it's all about you doing the correct thing, and we will continue to mark you accordingly. Okay, the second calculation where we need to calculate the current. So that means there must be an ammeter which is connected there. So remember, those devices that we connect to measure, it is, what is it? We've got an ammeter which reads the flow of charges or the current, and then we've got the voltmeter, which reads the voltage. What I want you to be aware of is that it ends with a meter, just like a water meter. So it's a meter that reads something. So those devices, they can be connected there. Not necessarily to a specific location, but it can be connected. Let's say an ammeter being connected in we say an ammeter is connected in series, so we can just refer to that as ammeter number 1. why ammeter number 1? That means it can be more. At the moment they say 1, it means it can be more. Sometimes if it's not more, you will see with it just being an ammeter. Then even with the V. So regarding the V, we can connect V across the 2 ohm resistor. We can connect it still across the 1 ohm resistor. You see, the moment we connect it there, then this one we may refer to this as V1, this one as V2. We can still connect it across that as a V3. Yes. So I've explained to you that for me, I had to find a way to cram these things, honorable members. I had to find a way to cram these things. So that's why I was saying the flow of current for me, I interpret it as the flow of water. Where it splits, I can see it nicely splitting there. The other water this side, the other this side, and then water and all of that. And then it joins and then it continues. And then when it comes to V, it's like in your house, you bought 20 volts of electricity, and then obviously if this is a charger, it's going to chow very little from that electricity. And then this one, if it's a TV, it will charge less, but more than that one of 1 ohm. And then, so the bigger the ohm, 3 ohms, maybe a stove will chow more. But at the end of the day, when you take the electricity chowed by the charger, electricity chowed by the TV, the electricity chowed by the stove, it must take you back to that because they all share all of that electricity. So obviously, the second question calculate the current, and we do know very well that this formula V is equals to IR, V is equals to E. Okay, so now V, it is that electricity of the house, which is 20 volts, and then the I, it is what you're looking for. Sometimes they would say, calculate the reading on the ammeter. They wouldn't necessarily say calculate the current, but you should just be aware that the ammeter reads the flow of current, or the current, yes. So in terms of R, do we not have R? We do have R. Our R is 6. We just calculated it. So now you will divide both sides by that. It's simple mathematics. Then I is equals to 20 that you divide it by 6. And it gives you 3,33. Then you can say amperes. And they did not specify to say to 1 or 2. If they did not specify, we always round it to 2. So this is the final answer that I rounded off to that. Okay, that should be done. That should be done. So maybe let's calculate the voltage across 1, the voltage across, what is it? That would be for V1, so it would be for V2, and this would be for V3. Okay, then it's fine. So again, we use that same formula where we say V is equals to IR. Okay, now it's necessary for us to specify and say, now we are doing V1. Can you see now? So that means for V1, we will also substitute that resistor number 1. But in terms of the current, you can't say current 1 because that same current is the one that flows through R1, R2, and R3. That's why you just say I there. You can't say I1. Okay, so now what is the reading on V1? It will be our current, which is 3,33 that you multiply by. It's just best to just put it inside the brackets with physical sciences. And it makes it very much easy. And then R1 is just 1. Okay, so that means that times that, it will definitely be 3,33 volts. So that means your charger is showing 3,33 out of that 20. So now V2, again, same formula. So that means V2 will be equals to the water that is flowing through that V2. It is that same water. That's why I'm substituting the same value. But the resistance there is 2 ohms. What will so 3,33 that you multiply by 2, it gives you 6,66, and then you say volts. That should be the end of it. So now when it comes to 3, same thing, and then there you're going to have R3, which will be equals to that same current. It is the one that is substituted there because it is the same current flowing there, but the resistance you put that. Then all that you need to do is just to with that, and then you end up having 9,99. Most importantly, it has to be in volts. So I can tell you now, honorable member, to say, if you take this V, you plus it with that, and then you plus it with that, it should give you something very much closer to that, if not equals to that. The reason why it closes is because you did some roundings, and you know that the moment you round an answer, it will never be exact, but very, very much close. So that plus that, comma, that, you see, it gives 19,98. But if you did not round this and you wrote it in full, then you're going to get exactly 20. So yes, that's how you would work it out. So now let's maybe try to look at another type here where for the same type of calculations, let me just quickly check what I've done there. Yes, okay. So let's say we have a separate battery there, doesn't really matter much. We are having this, and then it does that, then we end up having that, and then we end up having that. So let's say here we are having our resistor, there being 1 ohm, and then let's say here, what did I say there? Okay, let's make it 2, then it's fine. We'll say 2 ohms, and even this one, we will say 2 ohms, and this one, let's say 3 ohms. Again, let's say you bought 20 units of electricity. Okay, then it's fine. What are we therefore going to do? Obviously, the first calculation is to calculate R tot. Okay, most importantly, you start with the formula which says R tot equals 2 R1, that you plus it with R2, that you plus it with R3, that you plus it with other resistors which may be connected. Okay, so now definitely we do have that 1 ohm that we'll need to plus it. Okay, this one is R parallel, so that's why you write R parallel there. You can't substitute 2 and 2 because that section is in parallel. You can see your conducting wire, it splits at that point. So that is why very much important that you see that one is R parallel. But now this one, yes, it is 3. So that means you need to perform a separate calculation where you do R parallel. And this is the formula that you use where it says you take that, plus it with R number 2, can plus it with R number 3, can plus it with any other resistors which may exist. So what that means is that, let's say, for example, you had a parallel connection and it was like this, where you had a resistor there, you had another one there, then you had another one there. That would mean you would substitute there. If you had many of those, you would add another one and keep on adding. Okay, then it's fine. So the easiest way to deal with this is just say R parallel, you substitute. Then you say 1 over, what is R1 is 2. What is R2? It is also 2. Then what you do is just to say R parallel equals, then you rewrite that same thing. You see exactly what I'm doing. If you can do it this way, you will never go wrong. Then you just punch that on your calculator, because all that you're trying to do is to make sure that you rewrite this thing in the correct format, because that is 1 over R parallel, but you need to write it as R parallel because that's what you are looking for. Okay, 1 over 1, then you plus it with 1 over 1 on the side. You close that, you say to the exponent, nope, let me delete, and say to the exponent of -1, and then, okay, this is what I'm getting, it gives me 1. Most importantly, I need to say ohms. So that means actually my R tot will therefore be equal to that one plus this one for R total plus that other one for 3, that was that, it gives you 5, then you say it's got 5 ohms. So with you performing this calculation, you might be given, if you're like, can give you up to 5 marks. Very, very much important that you follow this calculation for the parallel. What it does is like we have converted that parallel connection into now being series. So you still have your 1 ohm there, and then this one we have combined it and then to make it 1. That's basically what we have just done. That's it, honorable member. So you've got 20 volts, you've got one ohm that. So it's like we've just consolidated or combined these two into a single one. But it's just to give you an idea of what the R parallel does. So you mustn't get to a situation where you redraw it like that, because you may be asked some more questions when it is like that as a parallel. Okay, then it's fine. Let's say we've got an ammeter connected there. So in terms of a V, okay, let's say this is a V1. Nay. With regards to V2, let me use a different color there. With regards to V2, honorable member, please be aware that V2 can be connected there. Nay. That V2, it is still the same as the V that you would get if it was connected there. Are you listening? That same V, it is the one that you would get if it was connected like this. So it's more like, what is it? A potato. They've used it to do it's mesh. Is it mesh? Yes, I think it's mesh. And then the other one, it could be those potato chips. Then what else can potato do? What else can potato do? You know that salad which is mixed of mayonnaise, is it mayonnaise or mayonnaise? It doesn't matter. And also some boiled eggs there. And yes, a lot that you can do with a potato. But at the end of the day, it remains a potato. Yes, you heard me correctly, a potato. Okay, then it's fine. So in other words, I'm trying to emphasize that V can be connected like that, like that, like that. On a parallel connection, it will still be the same. So that means if this V here, it's 70 volts, even this one automatically, it becomes 70 volts, 70 volts. Very, very much important on that one. Okay, then it's fine. Then this one would be V3. This one is in series. So if it's in series, it's what you already know. Okay, so the calculation that we now need to do, I think it's an easy one, which is what? The current is the current. Again, it is the current, yes. But it's fine, we'll just say V is equals to IR, whereby V, it is that one of 20 volts. I, it's what we are looking for. R, we just calculated it, it is 5. So that means our I will end up being equals to 20 divided by that. I think that should be 4. And then what am I writing there? It should be 4A. Otherwise, if it's like that, it's a big wrong. And let's say 20, don't want to make mistakes there, 25, yes, is 4. So that means the reading on the current or the reading on the ammeter, and you say it will be 4 amperes. See now. So now let's calculate V1, V2, and V3. Maybe let me emphasize this part, honorable member, to say the reason why this V, that one, and that one is the same, it's not necessarily because these resistors are equal or they are the same. Even if this one it was 2 and then this one it was 8 ohms, what I explained on or in blue, it remains as it is. I hope that part is clarified. I wonder if there is someone who was wondering, okay, is it because they're the same, or what if? I think that is clarified. Okay, so now when it comes to other V's, you will still say V is equals to IR. This time around, you calculated that and then you multiply it by 1 ohm and then it gives you 4 volts. So that means, I'm sure you are not lost. This is the one that I was calculating where the R is that. So for this one, we obviously are going to specify and say for that one, the V that we are calculating is for the parallel section. That's why we will do it like that, whereby in that parallel section, if you are going to use the R that you calculated when you were doing the R parallel, for example, we do know that we're calculating V on the parallel section. So if you already have that I from the reading on the ammeter, or the I of the series, or the I for the external, the unsplitted one, then you will therefore multiply it by that R parallel, which means you will therefore have your 4 that you're going to multiply it by your R parallel. I think you got it to be 1. So that means this times that, it will also be 1 volt. I think that part makes sense. Yes, the R parallel that we calculated, it was 1. Yes, 1 ohm. Okay, then it's fine. So now we calculate what is it, V3, that was V1, and then that was V2 for the parallel across the parallel. And this is I, obviously R for the 3 ohms. Then what is I? It's 4, that you will multiply it by that being 3. And then what is that times that? Definitely, that will be 12. Most importantly, you will need to say V for the volts. Okay, so what did I say? I said, if you see now, the nice one is this one, because we did not vector, round off. So V being 4, that you plus it with 4 is already 8. If you plus it with 12, it gives you a total of 20 volts. So you see, it takes you back to the electricity that you bought, those units. So that's how you would, that's how you would easily work it out. Not that much complicated. I think it's a straightforward thing that you can do. So yes, this is the beginning of this type of problems. I'm just hoping that as time goes on, you will be ready for some more of this type of problems, but where questions may be a little bit tricky, but there's nothing tricky there. Trust me when I say, if you can master these basic calculations, everything is going to make sense. Where now, for example, they can connect this being ammeter number 1, they connect, let's say, ammeter number 2 there, and they would connect ammeter number 3 there. You see those? Then you just need to know that if this is the water, and then when it gets there split, it means the water that is flowing through this side, when you add it with the water that flows through this side, they should take you back to that original water of 4 ohms, and then it connects as 444. So that means throughout the current is 444. Everywhere it's 4444, except that section it splits. So when we do further calculations, it is to just try to figure out how much of current is flowing through this side, how much of current is flowing through this side. With this one, we can easily tell. Why? Because we can see that the resistance on this side is exactly the same resistance on this side. So that means it splits equally. The only way something can split equally, that's if it's been divided by 2. The moment you divide something by 2, it means you are cutting into 2 equal halves. So that means, in other ways, 2 amperes will flow through this side, and then 2 amperes will flow through this side. I'm just saying it comes in as 4 waters, and then it splits 2 waters this side, 2 waters this side, and then it continues as 4 waters until it gets to that as 4 and splits 2, 2. But otherwise, if let's say here it was, let's say 3 ohms, and then here it was 17 ohms, then it wouldn't be equal. So those further calculations will be trying to figure out if it's not equal, then what would be the current flowing through this side? What would be the current flowing through this side? And that should be the end of it. Yes. Okay. I'll leave it here and say until we meet. Okay. Just see here. I hope I'm not